Well, congratulations. I'm assuming if you're here, you're feeling like you're an expert on molarity and concentration. Today we're going to talk about dilution, so how to change those concentrations. Something I mentioned briefly in the last lesson is the definition of this, a stock solution. So what happens at school is we order stock solution for things like acids, all right? And when it comes as a stock solution, it's a standard aqueous solution. It is a known precise concentration. So for example, the acids that we order, hydrochloric acid, sulfuric acid, and nitric acid, these all come with a standard or stock concentration of 12 moles per liter. Often, for us at school, it's always we need to dilute these stock solutions to make them safer, also more usable, and we get the same results with 1 mole per liter for a lot of experiments that we would with 12 moles per liter. So that actually lets us make that last longer because we have some limited budgets. And because if we look at all of our science department, not everyone's a chemistry teacher. I tend to be the one doing these dilutions. If you ever come into our prep room, you'll see I've put up several pages of instructions to help anyone who's trying, including what you're going to learn today. So when we dilute it, we're going to talk about a little bit of an analogy first. This is my glass of, I don't know, I made some orange Gatorade. Okay? So this, Gatorade. It's very concentrated. All right? It is full of those Gatorade powder particles. But when I taste it, I find, oh, that's way too strong. So what would you do? It's too sweet. Probably you'd say, well, add some more water to it. Or, dilute it. So I'd say, great idea, guys. Thanks for helping me out with that. Now, does the amount of powder that I put in change when I dilute it up to the top? So if I add more water, this is my loose attempt at showing you that it's dilute. The amount of Gatorade that was put in here has not changed. They both contain same amount of Gatorade. Both contain same amount, let's say, of Gatorade powder. What's actually changed is the volume of water in each and the overall volume of the solution. And that's what we're going to look at today. We're not changing the amount of active chemical, let's call it. We're just changing the concentration. Okay? So for example, I could say that N1 equals N2. And what does this mean? This is Gatorade moles. We're going to talk about moles of Gatorade. In situation 1 and 2, it is the same amount of moles. And hopefully we agree on this. Well, what do we know about the concentration for molarity, for molar concentration? It's C equals N over V. If I were to rearrange it for N, it would be C times V. Think back to substitution in grade 10 math. This equal sign means that I can, yes, it's a calculation, but it also means I can replace it. So the number of moles is equal to the concentration times the volume. That means that the concentration times the volume in my first glass of Gatorade would give me that number of moles. Well, that number of moles hasn't changed. So that means it would also be equal to the concentration times the volume in the second glass of Gatorade. And guess what, guys? That's our formula for the day. Boom. Done. C1V1 equals C2V2. We've got initial and we've got final. Okay, the ratio of concentration and volume doesn't change. So what I can do is I can use this formula to tell me, well, how much should I use of my original solution to dilute it to a known volume of my second solution. Obviously, we're going to do some examples right now. Okay, we're in the prep room. I need to do some dilutions. I know for the lab we're doing, I need 100.0 milliliters of 0.300 moles per liter of nitric acid. the stock concentration is 12.0 moles per liter. So how much stock acid do I need? And I need to know how much distilled water as well. Should be mixed. Take a moment here to identify our knowns. We're seeing some numbers, but see if you can match them to what variable they might be. So initial concentration is 12.0 moles per liter. And if you're sitting there saying, Miss Morton, I called these the initial, that's fine, guys, as long as you're grouping the right concentration and volume together. V1, we don't know. C2, I want 0.300 moles per liter. And V2 is 100.0 mils or 0.1000 liters. I have to have it in the same unit. So let's calculate. Up first, what is my final volume going to be? We'll start with C1V1 equals C2V2. I like to rearrange before I sub in. You may sub in before you rearrange. It's all the same thing, guys. So that would give me V1 equals C2 times V2 divided by C1. Now I'm going to sub in. 0.300 moles per liter times 0.1000 liters divided by 12.0 moles per liter. And when I do this math, it's going to give me a volume. So 0.3 times 0.1 divided by 12, that's 0.0025, and I have 3 sig dig, so 0.250 liters, which I can round to 2.5, not round, sorry, convert to 2.5 milliliters. Right. So I see that 2.5 milliliters of stock acid, 0.50, are required. Now, that's just part one. The other part is I said what volume of distilled water. And if you're saying 100 mils, you are wrong. Because we're not mixing a solid solute anymore. We're mixing a liquid. We've already got 2.50 milliliters of liquid. If I add 100 milliliters, my V2 is now going to be 102.50. So what can I say? Well, V acid plus V water will equal my final volume, right? Great. That means that my volume of water will be equal to 100.0 milliliters minus 2.50 milliliters, which leaves me with 97.5. We're looking at decimal places now. Milliliters. So 97.5 milliliters of water are required. Now, not that you guys are necessarily doing any acid dilutions at home, but something to note, and I'm just going to write it here because it's very, very important. We add acid to water, not water to acid. So if I was making this dilution in the prep room, I would have 97.5 milliliters of water in a beaker already, and then I would add the 2.50 milliliters of acid. And that's because when acid is diluted, it's actually what we call an exothermic reaction. It produces a lot of heat. And so if it's a small amount of water, like even when I start pouring, a little bit of water being added to that acid creates insane amounts of heat. It can actually crack the glassware, and no one wants that, right? So just something to be aware of. Ready for another problem? Yeah, you are. I'm going to leave that up. Okay, problem number 2, and that's it for today, guys. It's a short one. Press pause if you need to copy this down. I'm going to keep going. A solution of copper 2 chloride is 0.100 liters and has a concentration of 0.1487 moles per liter. It's diluted to a final volume of 0.170 liters. What is the new concentration? Identify what's C1, what's V1, what's C2, what's V2. Look at C1 is 0.1487 moles per liter. V1 is 0.100 liters. V2 is 0.170 liters. And C2 is unknown. So when I rearrange, I get C2 equals C1 V1 divided by V2. Let's do the math. And I get 0.087. I need 3 sig digs, so 875 moles per liter. The new concentration is 0.0875 moles per liter. And we can just check, does this make sense? The concentration has reduced from the initial. That makes sense because the volume increased, which means we added more water. We diluted it. If you got a higher concentration, something went wrong. And that's the end of our dilution note for today. That's the end of our lessons for this week. What you have left to do is, again, some textbook practice questions. And then our assignment for the week, I've put it in the quiz category just because I needed that setup. So I actually called on a friend. A good friend of mine is a pediatric ICU nurse, and we worked through some medical dilution problems that she does on the job. So these are not some, sometimes we do some silly textbook questions. This is legit nursing jobs, and they dilute it using these formulas that I'm teaching you. Make sure you pop in if you have any questions, send me a message, but there is no final weekly quiz for this week. It's my little gift to you. And you have up to 3 attempts on that assignment. So if you get one wrong, try and figure out where you went wrong. Thanks a lot for popping in, guys. Have a great day.